Hi guys, welcome back to Shabest online tutorial. In today's tutorial, we're going to learn how to find the fifth degree Maclaurin polynomials of this function. If you are new here, consider subscribing to my channel and also follow me on Facebook, TikTok, Instagram at Shabest online tutorial. The question on the board reads, find the fifth degree Maclaurin polynomials for f of x is equal to exponential x at c is equal to 0. So let's get started. Solution. So the first thing we're going to do is to write the general formula for Maclaurin polynomials. And the formula is given as what? P subscript n of x, which is equal to summation as n ranges from 0 to infinity, f at n derivative of c, then multiply by what? X to the power of n all over n factorial. So this is the formula, the general formula for Maclaurin polynomial. So in regards to this question, the question says the fifth degree polynomial at c is equal to 0. So we're going to have p sub the fifth of x, which is equal to summation as n ranges from 0 to 5, f at n derivative of 0 in place of c is going to be 0 multiplied by x raised to the power of n all over n factorial, where n ranges from 0, 1, 2, 3, 4, then the last one, which is 5. So the next thing we're going to do is to write the function. The function given is what? F of x is equal to exponential x. So at n is equal to 0, we are not going to differentiate this function. And c is equal to 0. So we're going to have f of c, which is the same as what? F of 0, which is equal to exponential. Anywhere we see x, we replace 0, which is equal to positive 1. So the next thing we're going to do is at n is equal to 1, which implies at first derivative of this function, I'm going to have f prime of x at first derivative is equal to, if you differentiate exponential x, is the same as what? Exponential x. Then substitute at f prime of 0 is equal to exponential raised to the power of 0 is the same as 1. At second derivative of x is equal to, if you differentiate exponential s, it will still give us exponential x, and f prime of 0 is the same as what? Exponential 0, which is the same as also 1. So if you continue differentiating exponential x, is going to give you, even though you differentiate at f at 100 derivative of this function, it will continue to give you exponential x. So at fifth derivative, we're going to have what? F at fifth derivative of x is equal to the same exponential x. Then f at fifth derivative of 0, which is the same as exponential 0, which is the same as 1. So if you continue, it will still give you 0. So that is why we skip third derivative, fourth derivative, then at fifth derivatives. Now the next thing we are going to do is to get the polynomial. So the formula is given as p subscript 5 of x, which is equal to what? It's equal to summation of f to the power of n of 0, x to the power of n all over n factorial. So at n is equal to 0, we have 1. So in place of f at n is equal to 0 of 0, it's going to be 1, then multiply by x raised to the power of 0 all over 0 factorial. So at n is equal to 1, we're going to have what? Plus, if you substitute 1 here at first derivative, we still have 1. Going to have 1, then x to the power of 1 all over 1 factorial, plus at second derivative is still 1. 1 multiplied by x to the power of 2 all over 2 factorial, plus at third derivative, we're still going to have 1, which is the same as 1 multiplied by x to the power 3 all over 3 factorial, then plus at fourth derivative, we're going to have 1 multiplied by x to the power 4 all over 4 factorial, then plus at fifth derivative, we're going to have 1 multiplied by what? X to the power 5 all over 5 factorial. Now the next thing we are going to do, this is to simplify. P subscript 5 of x, which is equal to x to the power of 0 is 1. 1 multiplied by 1 is going to give us 1. Then 1 divided by 0 factorial is the same as 1. 1 divided by 1, we're going to have 1. Then plus 1 multiplied by x to the power of 1 is the same as what? X to the power of 1, which is the same as x all over 1 factorial is the same as 1. Then x divided by 1 is to give us x. Then plus 1 multiplied by x to the power of 2 is the same as x to the power of 2. Then 2 factorial it implies what? 2 multiplied by 1, which is 2. So in this place, we are going to have a 1 over 2 x to the power of 2. Then plus what? 1 over 3 factorial is the same as 3 multiplied by 2 multiplied by 1, which is going to give us 1 over 6 x to the power of 3. Then plus 1 over 4 factorial is the same as 1 over 24, because 4 factorial is 24. Then multiply by what? X to the 4th power. Then plus 1 over 5 factorial is the same as 1 over 120. 5 factorial is 120. Then multiply by x to the 5th power. So this is the 5th degree Maclaurin polynomials of this function, exponential x. Thanks for watching, and please don't forget to subscribe to my YouTube channel. Also follow me on Facebook, TikTok, Instagram at shabest online tutorial. Thanks.